It's great that you came. Thank you, especially on Sunday, to listen about streaming. I'll give you a smoothie presentation about real-time data processing, about the issues. It would be an introductory presentation. A couple of things about myself. Why am I speaking to you about it? I'm with Tinkoff, manager of the ETL platform, real-time delayed processing. So the platform that allows us to process data. And the reason I do it is because I'm doing this for the last many years. I come to conferences and explain those things. First of all, why would we need data in real time? Why do they come here? Most of the data in the current world are in real time, client transactions, whether the person would send something to support chat. We want to know this. So we have great use cases who would enable us to react not the next day, but today, right now. And most often, it's used for anti-fraud. We cannot react next day if someone is controlled by the fraudster or wants to do a fraudulent transaction. We cannot come tomorrow. We need to do it today. Same with marketing. We want to offer something to the client, the most relevant. For that, we need to know where he clicked, what were the purchases during the day, and waiting for the data to come to the storage and be analyzed and be processed next day is not good. And the last thing is investing. If we want to make decisions in real time, we do need the data in real time. Of course, there's many other use cases, but clearly we need real-time data. So let's see what I'm going to tell you. And we do need to upload the data from somewhere. This approach has a lot of pros and cons. I will also discuss them. I'll talk about security. And in the end, I will tell you about how we can use the data that we uploaded. Where do we store the real-time data? In reality, the industry has Kafka that solves most of our issues. There are alternatives, and I will not be touching on them because everybody uses Kafka, and you need to know about it. So I'll give you 3 slides about Kafka because it's basics. The easiest definition is distributed, replicated messages log. Distributed means that you can write to Kafka by many applications, and the workload will be distributed between the brokers. Those are separate servers, separate computers. They can be placed in different data centers, and that's how we even the workload. So Kafka is easy to horizontally scale, and of course it has to do not only with reads but also with writes, and the workload will be distributed. The second thing that you need to know is that the log is replicated. The data that is sent will not be lost. By default, they will be sent to other brokers. If the server has crashed or turned off, we have that data on the other servers. You can set it up whether you want to replicate the data synchronously or asynchronously. The log will be the data structure that we can only append. Why is it important? Because we just need to remember it. We can read the data from different places. We can come back and process the data again. In Kafka, the data is stored for some time, not deleted after they have been read. And you can also always come and read the data again. Okay, so you would like to load the data in real time, you want to access the data in real time, and the simplest approach would be to take our application and send the data to Kafka. Imagine the user has a backend, the data is sent to the backend and then sent to both the database and Kafka. But if you have hundreds of applications, that would take a lot of time. And it's not acceptable to increase the response time. So when we send data to Kafka and have high load, then yeah, it might take time. And we need to solve the crashes. We need transactions for that. Imagine you've sent some data, but at the transaction stage, something broke. Should you send two messages to Kafka, or what should you do? Those trade-offs needs to be thought through. Second option is to use CDC. What this abbreviation means, I will tell you a bit later. But you can have a look ahead the chart at the slide. So there's a backend, then we write to the database, then we can go and read the data from Kafka. So to take the data from the database, it's Kafka Connect. It's a well-known application. I'll tell you how to run it. And there's another project called Debezium as part of Kafka Connect. Let me give you an example. We have a table with reviews. You give me different scores as a review, and we want to replicate everything. So look, Alex understood everything and put a 5, and Piotr did not understand the presentation and gave me a 2. So we have Kafka Connect. We create a Kafka connector that takes that data. So it takes the table and sends it to a Kafka topic. And then the most interesting part starts. The CDC, change data capture, starts. Look, Peter changes his review to 3. We will use Postgres as an example. So Postgres would parse the change, the row will be updated, and the connector would know, knowing that Postgres has this log, and write this event to Kafka. So it takes like tens of milliseconds. So the delay between the event appearing in the database and going to Kafka is very small. So we capture the data and publish it to Kafka. But you would ask, why is it better than a batch? Let's first of all ask what the batch is.
Чем это лучше бача? Что вообще такое батч?
Why is it better than a batch? What is the batch? We take a pack of data from time to time, from somewhere.
На примере этой таблички давайте представим, что в нее добавилась еще одна колонка updated@. То есть
Imagine we have a column with the date of update or time of update. First of all, what the batch would do is take all the data and then solve the discrepancies. Imagine Peter has changed his review to 4, and our process comes at, say, 12:10, 10 minutes past 12, and takes everything from 12:03 to 10 minutes past 12. And we see everything that's changed in the last 5 minutes. So Why is CDC better than
CDC, как я говорил,
batch
вы
capture?
получаете задержку в десятки
In
миллисекунд.
CDC, you get
Как вы
a
настроите,
ping of
выставляете
10
секунды,
milliseconds delay,
минуты, а чаще всего
but in batch, you would
то есть
usually have
целые процессы приходят раз в
minutes
день,
or seconds or
забирают из
days
базы
even.
и публикуют куда-нибудь
So
там.
it will take a lot of time to take the data from
Почему
the
они делают это
database
каждый день?
and then
Потому
publish
что на
them to the
самом
data
деле
storage.
батч сильно
Why
нагружает
is it
базу.
so?
Если мы каждую
Because the
секунду
batch
базу отправлять
would
через
load
запрос,
the
база
database a
или
lot
умрет,
if we
или
send
обслуживать
every
запрос. А нас это не устраивает. CDC
second
же
a
базу не
select
нагружает. Просто
request
маленький лог
to the
публикуется внутри
database,
базы, и
it
как
will
бы забирать его сильно дешевле с точки зрения
put the
нагрузки, чем
database down.
постоянно полить базу
CDC
запросами.
is a
Ну
much
и
smaller
последнее,
load.
вы не пропускаете
It
изменения
just
данных
takes
из-за
specific
скорости
data.
CDC.
And
Давайте быстренько
moreover,
примере.
you don't
Представим,
lose
что у
your
нас тут
data changes
Петр,
when
которому
you
мой
use
доклад не
CDC.
нравится,
Imagine
в какой-то
Peter
момент говорит, блин,
doesn't like my
доклад на самом деле
presentation
классный. И мне
and
поставит
says,
пятерку,
well, yeah,
12:04.
okay, it's a great presentation,
В
and
12:06 меня
gives
это
me a
сразу
5.
на тройку, потому
But
что,
at
ну, почему?
12:06,
И вот это
it
изменение, если мы
decides
забираем, например, раз в 10 секунд
the other
событие,
way
мы
around.
потеряем, потому
And
что
if we take
оно
the event
произошло в
every
какой-то
10
реал-тайм, мы
minutes,
никогда не узнаем, что
we
у нас
will
система
have
менялась,
this
и
as
никогда не
part of the
узнаем,
batch.
какой
So
конкретный
we will
результат
never know
сегодня
that
мы
the state
хотели
has
собрать узнать.
changed. And I would, of course,
Окей,
be happy
быстренько расскажу о
to
том,
know
как
about it.
вам это все попробовать локально за 5 минут,
Let's talk
чтобы, если у
about
вас этот доклад
trying this
вдохновит,
all
все-таки
locally
попробовать и
within
прям
5
результаты
minutes.
поднять.
So if you are
Что вам для
inspired
этого нужно?
after
Нужно
my
просто
presentation,
настроить,
you would be able
возможность, не знаю,
to
в докере поднятый код,
run this all
предыдущий
yourself.
на тесте.
Imagine we
Что
have
нужно сделать?
Postgres.
Нужно, во-первых, включить в нем возможность
What do you
репликации.
need to do?
Это вот команда, чтобы
You need
поднимать Postgres
to
с логической
enable
репликацией
publication
включенной.
and enable
Затем
replication,
нужно выдать роли на репликацию,
and
создать юзер.
then you need the roles,
Про безопасность, но
create the
это
user.
быстро делается. Разрешить
So
сетевой
this is all
доступ.
about security.
Самое важное — создать replication слот,
Enable network access, and
которые записывают
create
каждое
the
изменение в базе
publications.
в лог,
So
файлик.
those are the standards that would
Допустим, вы все
put
это сделали.
everything
Здесь детальки есть по
to the
ссылке, если
log.
хотите почитать. Дальше нужно поднять
So you
Kafka
can
Connect.
use this
Я
link
уже
to
говорил,
get
что
more
Kafka Connect — это
details.
open source
Then
приложение.
you,
Естественно, поднять его довольно легко.
install Kafka
Для
Connect.
него нужна работающая Kafka.
It's easy to deploy. You need Kafka. You
Поднять
can
Kafka Connect
use
легко.
Docker
Пулить
to
все
deploy
образы,
it.
доступные в open source, и
You
запускать.
pull
Кроме
the
Kafka Connect вам понадобится схема registry.
images.
Маленькое
Then you
приложение,
need
которое
the
собирает
registry
схему
schema.
в таблице есть какая-то
There's a
схема,
small
в Kafka тоже
application that
собирается схема,
saves the
вот ее
data
нужно где-то
schema.
хранить.
So
Я
you'll
вам
need to
вывел на
store it
слайд,
somewhere.
чтобы потом можно было скачать презентацию, файлики Docker
I put it
Compose.
on a slide. You need a
Зайти,
Docker Composer.
и оно, по идее, должно
You can just
коробке
copy
Docker
this,
Compose
and
запуститься.
out of the box,
Здесь без
the Docker Compose app would run.
не копируется. Вот,
For some reason, you cannot copy with those numbers,
ну и последнее, что
so
вы сделаете,
use the
когда
numbers
подняли
separately.
Kafka Connect у себя на машинке, к нему нужно отправить
Last of all,
да, создание
you
коннекторов в Kafka
deployed the
Connect.
Kafka
Вопрос
Connect,
одного
and to create the
вызова, скорость
connectors
вызова,
in
который
Kafka
вы
Connect,
отправляете,
you need the
указываете
REST
ему там эти
request,
простые настройки,
REST call
типа адрес базы,
with
список
those
таблиц, которые
simple
хотите реплицировать,
settings
и
like
у
the
вас
database
все
address,
запускается
the
на
list of
самом деле.
tables,
Настолько просто это
and
сделать.
everything works, and replication
Ну и,
starts.
естественно,
It's
возникает
that
вопрос,
easy.
блин, если за 5 минут можно все поднять, все как бы
So
одним местом
if
работает, ну,
it
конечно,
takes just
есть
5 minutes
проблемы.
to run,
И начнем мы так это с
why
самых
all the
базовых.
issues?
Что вообще, в чем проблема со стримингом? Есть
Let's
такая
start with the
штука,
base itself.
известная
What's the
по
problem with
истории
streaming?
проблем с определенными системами. Это
There are two
доставка
issues,
один раз,
very
скорость
famous
сообщений и доставка ровно один
joke.
раз. То есть это
Uh,
очень точно отражает проблему.
the
Собственно, с этим мы сейчас разберемся.
only once delivery and only once delivery.
Что у нас не так?
The first issue is the
Что у нас не
duplicates.
так с дублями? Как они могут возникнуть?
What's wrong with the
Быстренько
duplicates?
разберем на примере, чтобы было понятно, что дубли, они как бы
Let me give you an example.
возникают
The
везде.
duplicates are very dangerous
Представьте, что у вас
and
в
they
Postgres есть максимально
appear
простая
everywhere.
табличка,
Imagine you have in
значение
Postgres
одного
a simple
хранителя,
table
они публикуются,
with the
наш коннектор их забирает,
values from 1 to infinity.
возникает
Our
новый,
connector would take them,
только оно публикует их в топик,
publish them into the topic,
есть у него
and
отдельный
save the
вкладки, в
progress.
котором он хранит, что вот,
There's
например,
a topic
последний
in
раз
Kafka
вычитал сообщение под номером 3.
where he
Он
would
это
tell
сохранил,
us that
появилось
last
новое
thing he
сообщение, он
read
его
was
записал,
message
и
number
в
3.
этот момент
Imagine now you have a new message,
опять же, кто-то
and at
возразил
this
себе,
point in
как бы
time,
постоянно
the
происходит.
connector is
И мы
broken.
не успели
Someone
записать
has
наш
pulled the
прогресс,
plug on the server.
значит,
And we did not have time to record our progress, so the connector doesn't know when where it stopped. So when he restarts, he would see that the last message it read was message number 3, and then it gets the number 4. So it's very easy to get duplicates, and all the systems go down, so you will have them too.
Который использует большинство компаний, на самом деле мы тоже используем.
Option number 1
именно его. Это разобраться на стороне читателя.
is what we use in Tinkoff is to understand what's going on the user's side. Understanding the duplicates on the user's side is quite easy because you have transaction number or log sequence number, LSN. So every transaction would have a unique LSN, and the consumer receiving the message would see that, okay, I saw this message, it's a duplicate, I skip it. But it requires specific development on the client. A new way would be to use the latest function of Kafka Connect. It's an experimental one. Deliver only once delivery to the source connector. We tried it, but we did not succeed with launching it. So we use the first option, but we look carefully at the second one. It's one setting in Kafka Connect, and you get only once delivery to the topic. The second issue is the continuity, end-to-end continuity. Imagine you have database of users and emails, and as part of one transaction, you change both the users and the email. So we have topics, and we want to put them to another database. One message worked, and second one doesn't. So it's still in the topic. The system on the right is inconsistent compared to the system on the left. So the source of truth is different. And it's important to remember that consistency is very important. So at some point, you will get the message, and the systems will be consistent. But if you want your analysis to have consistent data, you need to check that everything is consistent. Or use the batch load that would upload all the transactions. And the last thing, in terms of the issues, they are endless. I usually present the data format, or what do you do if the servers break down, or if you don't have the network. But if you want to dive deeper into the topic, then that's a separate discussion. But because we are talking security, then let me tell you what you should do about security. What are the attack vectors for our data? If we decided to upload all the data to Kafka, then it's a very lucrative thing for the thieves to steal them. And the main option would be to manage access to Kafka. And there's an access control list mechanism, what you can read, what you can write, very well described. So feel free to protect your data. This is the first thing you can do. And the second thing is to log the user access. At some point in time, you will get a situation with the user getting access. And the Kafka cannot create that log for an audit. So you take a debug log from Kafka, and because it's a debug log, there's a lot of messages. So please remember that you can run out of space, and this thing will be nice for you to have, because incidents will keep happening, and you will need to know who got the access. Second thing is accessing Kafka Connect. There's no data there, right? Why would you need it? But actually, Kafka Connect is a one big application that has all the connections to the databases. So all the credentials lie there. And more often, people would
божественным пользователем. Этот пользователь умеет писать во все топики, и у вас
write to all the databases by just one user. So this is a great scenario for attack.
говорит,
Some
мне данные из
malicious
базы с
user
персональными
would
данными в
come
мой
here
базисный
and
и Kafka Connect берет
say, hey, do upload
доступ в топик, допустим, нашего недобросовестного пользователя есть.
this data to the topic,
Что с этим делать?
or
Ну,
do
во-первых,
download
избавьтесь от
the
божественных.
data I require. So first of all, remove the
имел свои credentials для доступа в
God accounts.
По крайней мере,
Every connection should have their own credentials to Kafka. At least you would know who has stolen your data. It's not enough, of course. So, first of all, close the access to Kafka Connect. There's no network access besides us. Previously, we had in Raiffeisen, we had authentication for Kafka Connect. We used Keycloak, and somehow you need to authorize those requests or just close from the network. Close everything from the network. Also, it's important not to keep your secrets in plain text. Kafka Connect kind of implies that you can put the usernames and passwords in a config or put them to drive. Don't do it. There's a convenient way connect to Vault. You need to have a Vault, and by adding this string to Kafka Connect, you will have all the data encrypted in Kafka Connect. Imagine then that you have everything in Kafka and you need to derive some value from it. How do you do it? Kafka Connect gives you an option to log not only the uploaders but also the downloaders of data. So you can send one command to download to HDFS or S3 and run quick analytics there. And as I said, you don't upload just the latest state, but all the states of all the clients. So you can do easy time travel about, what was Peter's opinion of my presentation. You have all those messages. You can upload them to the storage. Also, you can use optimal storage, Postgres, whatever. You have open source connectors to analyze data. You want to analyze data in ClickHouse. Okay, download it to ClickHouse. Build a graph that is updatable. And one more thing, you can change your data. You don't want the data to stay as they are. For example, you want to join the emails to users or phone numbers. You can do it via stream processing framework that enables you, using Java, Python, or SQL, to process in real time with like 1 millisecond. Send your data process your data and send it to Kafka. Here's the set of calls to SQL that would read a lot of messages from Kafka, process them. Yeah, it's hard to see the logic here. Select, cast, transform. They use that logic and publish everything back to Kafka. My colleague, Maxim, will be talking about this at high load, and it's a great thing. The analysts, not knowing Java or SQL, will tell you about those things and how to use them in anti-fraud and stuff like that. What have we discussed today? Kafka is a standard. It's great to know how to use it. The Basium is the framework for capturing data and publish the data from the database to Kafka. Streaming has some issues, duplicates and consistency. Remember about security, authorize Kafka Connect, and encrypt your secrets. And also, it's easy to upload your data, join them, aggregate through some window. You would need stream processing framework for that, but you can have a look at this one in a separate presentation. Happy to answer your questions, and thank you very much for your attention. Thanks, Andrew. Thanks. Dear friends, let me remind you that we have 2 gifts for the best questions. Please do evaluate the presentation. Ivan did a great job. And first question, can we run CDC without Debezium or Kafka? Yes, you actually can. Debezium is used for about tens of tables, but for thousands of tables, we use the CDC that we created ourselves. We go to Postgres, we take the log, publication log, and put it where we need it. But Debezium is just easier. You don't need to hire people to run it. Have you compared Kafka to Zookeeper or Craft? No, not yet. We are still looking at this feature as a non-production ready, and nothing is guaranteed, so we are waiting for it to be production ready. But which databases besides Postgres can Kafka work with? Yeah, it can work with Mongo, MySQL, SQL Server. It can actually work with a lot of databases. So have a look at the Debezium site, and it works out of the box. The move of Tinkoff to Russia, did it affect the speed of streaming? The move. What does it mean? Maybe you were in foreign clouds? No, as far as I know, not. Streaming is as fast as it was.
Окей, друзья, возможно, вопросы из зала.
Still fine. Any questions from the audience?
Сейчас микрофончик поднесут.
Yep, sure. Wait for a moment and we'll bring you the mic. Hello.
Андрей, спасибо за доклад.
Andrew, thanks much for the presentation. I didn't get fully the case about CDC that you will lose 2 updates. No, it wasn't about CDC, it was about the alternative, which is a batch upload when we come and every 5 or 10 minutes we take data from the database. This is not a CDC approach, this is an alternative approach. Couple of slides ago. That would lose 2 updates. One, if we do not want CDC, if we want to run it in a batch mode once per day. But in CDC, it's not lost if you set it up correctly in Kafka. Thank you. Yeah, we have another question.
А как Kafka стала технологическим стандартом?
How did Kafka become tech standard, and what has happened to the similar technologies?
Kafka стандарт именно
Actually, Kafka standard, there's an alternative GMS protocol. When we send a message, sometimes in the use cases when you have a lot of consumers and each and everyone wants some separate piece of data, then yeah, you need a separate presentation. I think I did it. But then Kafka appeared. It allows for long storage of messages and they are not deleted. So I think it was the first one. The community is big. LinkedIn was supporting it. There was a lot of open source developers, and now we have even analogs of Kafka, not on Java but on C++. Or Yandex, they have created their own Kafka because they didn't like how it scales. Why is Kafka standard? Because the new options, they don't adapt the new possibilities like transactions. Yandex, I think they cannot do transactions. So those things, or maybe they can, or whatever. So some features that Kafka has lacking in Kafka. So new companies that copy Kafka are not adapted. And in Tinkoff, we are fine with
Так, вон там у нас еще одна рука.
with it. Okay, we have another question.
Ага, спасибо за доклад. Мне
Thank you.
хотелось бы услышать,
Thanks for your presentation. I wanted to ask you
как вы организовали
about
CI/CD, условно, потому что
Какую связь, извини, пожалуйста?
CI/CD. How did you implement CI/CD for the
то есть,
connectors?
понятно, можно там поставить какой-нибудь Kafka UI и накликать
For
коннектор,
example, you can
но потом
implement Kafka UI, but
миграции вы просто забудете, что вы вообще изменяли, и отслеживать как-то изменения.
because in the migrations, it will be hard to monitor all the
Кажется, я понял.
settings and parameters of Kafka connector. Okay, so you have a database address, but if the database is moved to some other segment, then just simpler. How do you add the new Kafka connectors? Well, actually, we have a centralized system. We don't have a platform approach. Like anyone can come and add a Kafka connector. We are doing this through a centralized system. All the network access is managed and centrally. So the user would work in a way saying that he or she wants to change this format or this table, and all the rights for user replication, for example, would be done under the hood automatically. So we don't give the users access to those rights. But how do you automate them? What is this thing that sends those requests to Kafka Connect? It's a Java API. So you created your own Java API that a wrapper that takes YAMLs from. Okay, thank you.
Отличный вопрос из бота. Понятно, когда нужно использовать.
We have different questions from the bot. It's clear when we need to use Kafka and when we don't need to use Kafka. Great question. There's a good article from the person who quoted that on the slide. When you don't need to use Kafka, there are plenty of cases when you don't have to use it. I just described one of them. You have this system where you don't need to store it for a long time, but you need to distribute it by a number of consumers. I have a lot of users' transactions, and Oleg, for instance, needs only the transactions of the users from Moscow. I only need the transactions of the users below the age of 10, and somebody else needs other transactions, but only the type of transactions through mobile apps. That's when you have to create a single topic for each user. It takes time, and the application triplicize it. But some box solution may allow you to use it straight from the box when the proper questions go to the proper queues. It's one of the use cases. So you'd better read that article. It's a great article about when Kafka cannot apply or be applied, rather.
Надеюсь, ответил на вопрос. Вот там еще один вопрос.
I hope this answers your question. And here is one more. Thank you for your presentation. Could you please tell us about how you correlate the database with the table, with the partitions in Kafka, and which ones work the best? Oh yeah, thank you very much. Let me tell you quickly. When we upload the data from the chart, this table normally has some primary key. So the message is, and I need to clarify, Kafka has topics, and inside topics there are partitions. They are all combined with one single topic, and the partition is just a way of spread the topic with brokers. You have 3 partitions, 3 brokers. Each broker has one partition. 1/3 of the data goes to broker 1, another to broker 2, then to broker 3. And these are the partitions. How do you spread data over these partitions? If you have a primary key, so all of the messages with the primary key, all of the conde all the Andrey messages, Andrey-related messages go to one partition. So by default, that's one type of distribution. There are different types of partition distribution, like round robin. It goes to the first one, then to the second one, to the third one. But here you have issues with the order of the messages, because messages to Andrey may go to different partitions, and somebody may read a message about me, which was sent later. They will send it, they will read it earlier. So by default, we use a standard way of distributing them with the primary key. I hope this answers your question.
Окей.
Mostly, yes. I can give you a hint to the articles where you can get into detail. Let's go back to the bot. Can you compress data before you send it to SDFS or S3 with Kafka? Let me answer this question as follows. You can point in Kafka the configuration of the topic where JZ should be compressed. Whether you can do it with upload of HDFS, standard HDFS and S3 connector have compression mode. So where you can put the type of compression where you upload it to HDFS. First of all, we decompress Kafka's message, we read it, and then compress it again. Exactly like that. Thank you for your presentation. Here's the question. When you need to tune up some pipeline on the side of the consumer, when he has received the data, is this batch method less stressed? For example, you may have the problems with joins. Yes, I was going to explain that. Your question is very good. I was explaining that part with the users and emails. So let me explain this on the, and in the background I will have this slide that will be more illustrative. It's much simpler, you are right. It's one of the use cases when streaming does not really apply, when you have a very complicated logic of the table. When, for example, there remains on the accounts in the end of the day dozens of tables, and it's very difficult to repeat this logic on stream. It was much easier to do it in their DB, join it, and then send a very big batch, send them as a very big batch. So when you use streaming, you need to remember about eventual consistency, and this eventual consistency really is in your way, whether these messages have been uploaded or not, whether we should start reading them or it's not the time. So I think batch is much better here. Another question. What is the difference between RabbitMQ and Kafka? First of all, if we Google RabbitMQ and Kafka articles, there are 5 articles analyzing the difference. They are all in English, but they are absolutely superb. Briefly speaking, the main difference is technology. RabbitMQ keeps the messages in memory, sends it to the signed users. As soon as they've read them, they are deleted from memory. Of course, you can put them on disk, but as soon as they are read, they are deleted. Kafka works differently. It writes the message on disk and log, and it will delete it after retention period, after a week. It doesn't care who reads this or not. It's written, it's left for a week. And consumers come in and they may read this message as many times as they want to before it's deleted. That's the main difference, and that's why it stipulates different use cases for RabbitMQ and Kafka. That's why they're different. Thank you. Next question. It's about Kafka Connect. It's about Spark streaming. Spark streaming, as far as I know, it's a similar solution of Kafka Connect. What's best for industrial scale application? You obviously use Kafka Connect. What are the minuses or disadvantages of Kafka Connect? Let me clarify. These are a little bit different. Spark streaming downloads data from sources, just like Kafka Connect. But Kafka Connect does not transform the data. Spark structure streamings can describe how to rename data, join the data, whereas Kafka Connect is quite stupid, I would say. It just goes there to Kafka, reads this, and that's how it works. So these tools are a little bit different. I think Kafka Connect is very easy to use a box solution for Spark streaming, where you have to have Kubernetes YARN, where you have to use different other resources for Master Spark. So it's a big scale project, unlike Kafka Connect. Kafka Connect is a box solution which is much easier. Other transformation tools are also good for changing. Flink may be a good alternative, and to Kafka streams there may be Apache Samsa, etc. So if you are interested about transforming the data, if you're interested about uploading the data, I think Kafka Connect is more than enough. It's more than enough, and it does not require much effort to launch and maintain. How do you work in different time zones? I'm talking about streaming here. Good question. It's about how we join the data in different time zones. What happened first. So I think it's more about data storage. We try, as far as I know, we try to keep it in FUTC. A lot of time steps are stored there, so it resolves the issue of time zones. As we set up the model, we try to put it in UTC. As for streaming, as far as I know, when Debezium uploads data, it uses this UTC format by default. So when we stream data, it's UTC which is used there, so the problem with time zones does not exist there. How should you work with Kafka when messages are no longer relevant, when the user is deleted and no other events need to be related to this deleted user? So here we use different storage ways. When there is a way of storing data, when we only keep the last key message in the infinity, the last key message, then it's simple. You change the location with this key, which is null, and when it sees this 0, null, it deletes this. But when we keep it for a week, that's when we start having difficulties. We can just wait for a week if we would like to delete it. Alternatively, I don't remember if there's an alternative at all. At the consumer phase, we may just highlight that these records are obsolete. There's no simple way of deleting data there. So I don't really know whether there's a box solution. Maybe it's just for the Federal Law 152 when you have to urgently delete the data from Kafka, but I don't know any other ways. What about monitoring of the Alert Connect UI IP? I gave a link to the JPoint presentation of mine. There are some alert rules that we use for Kafka Connect. From the box, Kafka Connect can give metrics to Prometheus, and that's how you launch alerting. But straight from the box, I don't know. Maybe there was some kind of a UI-related thing. We have the AKHQ that includes Kafka Connect UI. When you see which connector is down, what's the task, what's the cause for that error. As far as I know, there's Kafka Connect open source, which I don't remember the name of, but I think it will cover all of the needs for Kafka, Kafka Connect, schema registry. It's a great tool which I recommend. It's an open source one. Did you try to use streaming in
Да.
Kubernetes, I guess Kubernetes. Wherever I work in Rife, in Tinkoff, we all use Kubernetes, and it's very easy to launch. Kafka Streams was launched once. It's a Java application, stateless in Kubernetes. We did it in Kubernetes. We have a nice Kubernetes operator straight from the box. It's very easy to launch it, and you just send this to Kubernetes, and Flink launches it in Kubernetes. It works. It can be recommended.